Good evening, doctor and team. Yeah, thank you for this series of presentations. And my case of study today is going to be in regards to biodegradable magnesium glue in a biological medium or mass. This can be your body, it can be a liquid, it can be anything biological. And what we are going to use paraview for in this study is literally going to be to analyze the degradation corrosion of a screw in mass. How long will it take to dissolve when it is in a mass, and its reaction when it is in a mass? That is what we are going to do. In a nutshell, the goals of this analysis is to understand how the screw degrades over time in a simulated biological environment, to track to track the diffusion and concentration of degradation for products. For example, a magnesium screw, the one we are going to use, and some five functions we are going to use. You will see the other variables that we are going to use during this analysis in the next presentation. Analyze the solid to liquid transition. That as well we shall analyze through this presentation, and visualize regions of accelerated corrosion. And these help to determine whether where if there's corrosion in a place, then this screw needs to be removed, for example in a body, to prevent cancer and different other things. So this study is ideally um, going to be tackling that. So the variables that we are going to use uh, in this presentation are going to be a phi function, that is a phase field variable, and in the data set that we are using, the VTKs that we are using in paraview, 0 would mean degraded, and 1 intact material. Also, magnesium ion is one of the elements, the main elements actually we are going to apply filters on. And psi concentration, then labels, and the solid mass before it is actually fully uh, before we apply filters on this. We shall deep dive in the medical importances after I've presented. So the data set is got from Cargo, and I'll go ahead to show you this data. This is the data set that we are using. It's a number of VTK files which we've ingested into paraview. So this is the analysis that I already did. I'll go ahead and first remove that clip. So this is the biodegradable mass that we are acting on, and if you see these variables that we are applying, you realize that the mass looks like this. This could be your body. It could be something that something that dissolves, but take it that this is your body. And inside this mass there is a screw that we shall look at after we've trimmed and applied filters on this biodegradable mass. um, so when you apply a filter of a clip on this main mass, you will realize that you'll split it in half for you to see what is actually happening inside. And this is what is actually happening inside this mass. I'll go ahead and delete this for now, and I will apply this filter for those that I've already added. You will notice that after clipping this, you will see that inside this mass there is a screw, and this screw is degrading over time, and you will see reaction when different variables are are set, different filters of different variables. Now this is a phi function. You will realize that it is degrading over time, and if we are to play this after applying this mass, you will keep on seeing changes in this mass over time. I'll try to run this timestamp to a time of 45, and you will realize that it actually changes very, very significantly. This could be your body, and this could be a mass. And this concentration here shows that where you see this much red, the solid red, this shows that the metal is still intact, or the, ma- the variable is still intact. But when you with time, this shows that if this mass is eroding like this, with time it could cause challenges like inflation on your body or something like that. So we applied this filter of trimming this mass. Let me first pause this. Yeah, of using this mass, and we were able now to see within this mass. And this is the actual mass after we've applied a function of paraview called, just show it to you, just a minute. Yeah, we apply an invert, it will go back to the actual. But after we remove this invert and we apply, it will we apply this filter of invert, you realize that it will change. And if I want the mass to go back and isolate this, leave the screw inside the mass, I'll just apply the function again, and you will realize that this is the mass. This is the mass. So this mass, if we apply a phi function and apply it, then invert it and give it a value of 0, we shall now see a screw, and this screw is eroding over time. It is eroding over time. If we want to see the actual eroding points, then this is how this will be. But key in this is that paraview is used to represent uh, represent uh, things in 3D. It is used to make analysis and drills of how something will be done. For example, now this is a screw. A person can easily know that if we are to insert this screw, these would be the points of erosion on this. And you will notice that if we apply this timestamp on it, it will change significantly. So this is what majorly, this is the analysis that I used to on my VT case. But there is quite a lot. You can introduce this again. So this is the mass, and you will realize the point of erosion on this mass. Yeah, that's all from paraview. We shall meet in another series. But key in this, on how paraview can be used, it is used by doctors, both and both doctors and engineers. when they need to understand where an implant is likely degrading fast. This knowledge is crucial for implants design and ensuring that patients are safe when using these implants. Regions of accelerated degradation can lead to premature medical failures. Imagine they put something in your heart and it erodes faster. It erodes before it is actually it actually does what it was meant to do, or they insert something in your broken bone and it starts eroding, creating cancer, or they insert something in you and it is meant to dissolve, but in this case it doesn't dissolve. All these analysis can be done using these simulated environments, and paraview is key. Then also engineers can use it to analyze different patterns and predict more accurate um, material for usage and corrosion. For example, if you're going to put steel tubes into water, how long will they take to dissolve? How long will they take to erode, to rust? All these things can be used, and this is key in this. This was my presentation. I beg to submit. Thank you very much. Chibera Kenneth is my name.